Thank you everyone for coming to my PhD dissertation. The title of my thesis is A Crystalline Criterion for Good Reduction on Semistable K3 Surfaces over a p-adic field. The main objective of this work is to give a criterion for the good reduction for a semistable K3 surface in terms of its second detail cohomology group as a p-adic representation. We prove an analog of the Klykov's classification theorem of the central fiber on a degeneration of K3 surfaces that leads us, eventually, to the desired criterion. A K3 surface is a proper smooth surface over a field K, with irregularity equal to 0, and trivial canonical sheaf. A semistable K3 surface is a K3 surface with a flat proper model X over the ring of integers of K, such that, tail locally, their special fiber is a normal crossing divisor. We say that it has good reduction if the special fiber is smooth. A quadic in P3. The complete intersection of a quadric and a cubic in P4. The complete intersection of three quadrics in P5. And Kuma surfaces are examples of K3 surfaces. A p-adic representation V of the absolute Galois group of the p-adic field K, GK, is a finite-dimensional QP vector space, together with a continuization of GK. The main example, for us, of p-adic representations are the tail cohomology groups of smooth prop varieties. In particular, the second etal cohomology group of a K3 surface is a p-adic representation of dimension 22. In order to study p-adic representations, Fontaine introduces what we know as rings of periods, which are topological QP algebras, with a continuous action of GK, and some extra structure, such as a filtration, or a Frobenius endomorphism, or a linear nilpotent operator called the monodromy. Examples of these rings include B Hodge-Tate, B theorem, B Cris, BST, or B semistable, etc. Fontaine also observed that the Dieudonné modules D, defined as in the slide, reveals the important properties of the p-adic representations, as we will see on the next examples. The C conjectures now theorems. The crystalline conjecture, it establish a comparison isomorphism between the etal cohomology of the generic fiber, on a semistable model, with the crystalline cohomology of its special fiber. Taking Dieudonné modules, we get the Barthelot-Gus isomorphism. The semistable conjecture, it also gives us a comparison isomorphism, analogous to the previous one, but now in the category of logarithmic schemes. Now, we have the important theorem of faultings. Consider a proper smooth variety X over K, with a semistable model. If X has good reduction, then the p-adic representation H, I, tail of X is crystalline and always semistable. And no, for the case of abelian varieties, Iovata, Coleman and Buell, extent faultings result to a classification theorem. An abelian variety A has good reduction, if and only if its tail cohomology groups are crystalline p-adic representations. A has a semistable model, if and only if its etal cohomology is a semistable representation. The main result of my work is this classification theorem, but for the case of K3 surfaces, in fact, I proved more. I gave a p-adic analog of the Klykov classification theorem for a semistable K3 surface over a p-adic field, with minimal semistable model using the p-adic semistable monodromy operator NST. The theorem says that we can distinguish the special fiber of the model, in terms OT the nilpotency degree of the operator NST, letting us with three possibilities. In particular we have 1. N equals 0 implies the special fiber is smooth. As a consequence, and using p-adic Hodge theory, we got the following criterion. A semistable K3 surface has good reduction, if and only if its second detail K homology group is crystalline p-adic representation of the absolute Galois group of K. For details you can consult the paper with these results to appear soon. Thank you very much.